Hi guys, welcome to our lesson today on Wednesday, April 15th. Later this afternoon at noon, I'll be having a Google meeting at noon with periods 1, 5, and 9, and at 12:30 for periods 4 and 8. So I hope to see some of you guys there. I'm going to, after tomorrow, I'm probably going to put a quiz. It's kind of a practice quiz. It's not going to count as a quiz grade for you guys on this stuff, so you can check to see how you're doing on surface area of prisms and cylinders. So I have a triangular prism for you to try. Okay, this is a right triangular prism. So anytime we do a prism, what we've said is to find the area of all the faces and then add them all together. So you have 2 triangle faces and then 3 different rectangle faces. So it's a total of 5 faces. So for number 1, you should have 5 different areas and then add them up. Remember, the area of a triangle is 1/2 base times height of the triangle, and then the area of each rectangle is the base times the height of each, the height of each say it again. The area of a triangle is 1/2 base times height, or base times height divided by 2. The area of each rectangle is base times height. Okay, so you'll have those 5 areas that you'll add up, and the 2 triangle areas will be the same. I'll even give you the formula here for number 2. You should know it because you did it a bunch of times yesterday, hopefully on page 12, but the area of a cylinder, surface area of a cylinder, is 2 pi r squared plus 2 pi rh, and you can find this one in terms of pi just like yesterday. In terms of pi is fine to find that surface area. So pause the video and try it. Alright, hopefully you tried it. I'm going to go over the answers to both of these right now. So for the first one, okay, I have to find the area of the 2 triangles first. Okay, so it's going to be the front, the area of the front and the back. They're going to be the same. And then I have the bottom rectangle, let's see if I can just a little bit. Bottom rectangle, the left rectangle, and that right kind of diagonal rectangle, the one that looks like the ramp kinda. Those are my 3 rectangles. So the rectangles, I can do those ones first because they're the easiest. The area of this bottom rectangle is 5 by 10, so that's going to be 50 meters squared. The left is 12 by 10. 12 times 10 is 120. And this right diagonal one is 13 by 10. 13 times 10 is 130. So there's the areas of all my rectangles. I may have to do a little side problem here because it's a little bit harder formula for the area of a triangle. Remember, it's base times height divided by 2, or 1/2 base times the height. So to find the area of the triangle, write down base times height divided by 2. Well, the base, now I'm doing 2-dimensional here, so I'm only looking at this triangle right there. And since it's a right triangle, it says it's a right triangle right there. Alright, so the base of this right triangle would be 5, and the height, because this is 90 degrees, this would be 12 back here too. You could have looked at this rectangle. Alright, the height is going to be the 90-degree distance up to the top point there. So since it's a right triangle, I can say that that side length 12 is the height. So I have a base of 5 and a height of 12 divided by 2. 5 times 12 is 60, and 60 divided by 2 is 30. So, can't quite see that, there you go. So the front is 30 meters squared, and the back is 30 meters squared. So now I can go ahead and just simply, to find the surface area, add up all of those sides. So I got 130, 30, and 30. That's going to be 190. 190 plus another 50 here would be 240. And 240 plus 120 would be 360. So the surface area is 360 meters squared. Hopefully I did that addition right in my head. Okay. So that's how to find the area of any prism. If it was a rectangular prism, you just would have the area of 6 different rectangles here, and you'd add them up. We did problems like that on page 10. a bunch of rectangle ones. All right, for my cylinder here, it's standing upright, so 8 is my radius, and my height would be the distance between the circles. 6, that's the three-dimensional height, the height of the cylinder. The distance between the bases, just between the circles in this case, because the bases are circles on a cylinder. So everywhere I see an R, I'm going to plug in 8. Everywhere I see an H, I'm going to plug in a 6 into my formula. So 2 pi 8 squared plus 2 pi 8 times 6. I'm going to save pi to the very end because I have in terms of pi there. So 8 squared is 64, so I got 2 pi times 64 plus 2 pi 8 times 6 is 48. We'll double 64, we get 128 pi. And then we got to do 2 times 48, we double that, it's 96 pi. And then we're just going to add those two together, and you're going to get, doing it in my head here, 224 pi, and my units would be centimeters squared. Again, hopefully I didn't make any mistakes with adding in my head there, but it looks pretty good. So that would be my answer to the surface area of that cylinder. And by the way, if it didn't say in terms of pi, if it said nearest tenth or nearest hundredth, now all I would do is simply type in 224 times the pi button on my calculator, and I'd be all set. Alright, so I want to take the time to go over those step by step, so instead of just showing the answers on a couple of the problems. And now I'll show you the answers to the problems you should have tried last night on page 12, the odds. So I'll move it up here as you go. You can always pause it as you go. See if I can zoom in just a little bit here. There you go, it's a little better. So there is, well, there's the first 5 you can see right there, the work for the first 5 problems. You can see that I plugged in the radius for each one. The radius was 6 here. The radius, it's 4 all the way across, so that's the diameter, so the radius was actually 2 on this one, so I plugged in 2 for the radius. And here it said the distance all the way across was 12, so the radius was 6 on number 5. So everywhere I see an R, I plugged in a 6. And then I did the math from that point on, just carrying the pi all the way through. So I had 36 pi meters squared, 216 pi centimeters squared, 228 pi feet squared. If you need to see any of those longer, you just pause the video or you can rewind it. For 7 and 9, same thing. I plugged in this one 10 for the radius, 15 for the height, and I did the math, got 500 pi. And I plugged in over here 4 for the radius and 9 for the height, and again did the math, order of operations, got 104 pi millimeters squared. So those are your answers from last night. Alright, so tonight I have the very next page, page 13. It's a mix of triangular prisms, rectangular prisms, and cylinders. Kind of like the EP for today. So why don't you just try 6 of the problems here, and I'll post this on the Google Classroom as well. But why don't you just try like the left 2 columns here? So 1 and 2, 4 and 5, 7 and 8. Okay, so that leaves you with 3 rectangular prisms, 2 triangular prisms, and a cylinder. Just 1 cylinder problem, since you should have tried 5 of them yesterday. Alright, and then tomorrow I'll post like a little practice quiz for you guys to try. That'll be on the surface, mainly on the surface area of these 3 things. I might have a couple questions. I can't remember what it looks like on like identifying the shapes, like faces, edges, and vertices that we did earlier in the packet too. Alright, so go ahead and try these for this evening, and I hope to see you guys, some of you guys at least, soon on the Google meeting. Have a great day, and I'll talk to you tomorrow. Bye.